Welcome everybody to Mike's Morning Mug. And I do mean everybody because I'm making this one public. Usually this is a special feature of the Connected Universe portal, and only those who are time travelers within the Connected Universe portal will be able to view this entire thing. I usually post a couple of clips here and there, but you guys, everybody, is getting this full thing. So I'll give you a little bit of a taste of what you can expect on the Connected Universe portal. So, did an astrophysicist really solve the equation of time travel? So this is a question that has been posed to me several times here over the last few days. Been traveling, so I haven't really had too much time to really address it, but that is what I'm doing right now. And I am familiar with this astrophysicist, Ronald Mallett from the University of Connecticut. This is not the first time that he has talked about this particular piece of work and how we can utilize a black hole to time travel. Now, in this latest article, he's talking about actually being able to, at some point, build a machine that will be able to use similar properties to be able to travel in time. But one of the caveats is that you would only be able to, as far as going backwards in time, only be able to go as far back as when the machine was built, which is one of the principles that he talked about with the black hole. And then, well, let's get into it. For this particular morning mug, it's a little bit different than some of my usual ones, in which I will just take a topic and run with it for a little while over, of course, our mug of coffee. This particular one, I'm going to have to do a little bit of reading, and I apologize for that. But again, I have addressed his work, not specifically naming him, but the work of physicists in this field that have tackled this particular topic. And I deal with it right at the very beginning of chapter 11, or I call them cycles in this book. Chapter 11 on real-time travel and what real-time travel looks like. So I published this book last year, August 2023. This article is just coming out now, but again, his work has been featured many, many times, really talking about the same thing. So this is not new. I think the little twist he added on there was talking about it in building a machine. But our theoretical physics show us that the gravity of black holes is so strong that not only can light not escape it, but its gravitation field also bends space and time. As space stretches, so does time. Thus, a clock that is held near a massive object will tick slower than one held near an object that is much less massive. We briefly talked about time dilations back in chapter 2. In comparison to a clock here on Earth, a clock near a black hole will tick much more slowly. So if you could get close enough to the center of a black hole without crossing over the event horizon, at which point there is no escape, and return back to Earth, you will discover that time on the planet has passed quicker, and you will have traveled into the future upon your arrival. Physicists also believe that black holes can bend time so much that it can wrap back on itself, creating a loop that can take one back into the past, at least to the point at which the black hole was created. And see, this is where we get into his idea of building a machine, and you can only go back into the past to the point of when the machine was built, but this is a principle using the black hole. In other words, if you found a black hole that was created at the time of the Old Kingdom ancient Egyptians, then you could take its loop as far back as that. But if you wanted to travel back to the time of the dinosaurs with that particular black hole, you'd be out of luck. Of course, there are some logistical problems to all of this. First of all, the closest black holes to Earth, Gaia BH1 and Gaia BH2, are 1,560 light years and 3,800 light years away from us, respectively. We're not getting near those anytime soon. Secondly, in order to get that close to a black hole and be able to successfully navigate away from it, you would have to be traveling near the speed of light, and faster than the speed of light if you accidentally slip past the event horizon, in order to get away from it. Finally, the gravity of the black hole is so strong that you and your craft would likely have been stretched out in a grueling phenomenon called spaghettification, stretching you out flat like pasta and, essentially, destroying the craft and killing you. So the idea of using a black hole as a natural time machine really is not feasible. And so this is one of those questions that I get a lot during interviews, is on what does real-time travel look like? And I always use this example as one of the ways in which, according to our physicists, in the way that they are looking at this problem, it's just not feasible. We're not getting near a black hole anytime soon. And the process of taking ourselves around a black hole would probably kill us in the process. So it's just really not feasible. Now, I'm not trying to discredit Ronald Mallet and his work. I've never met him. I'm sure he's a very intelligent man. He's thought through this problem quite a lot. I understand that he has a very personal tie to it. His father died when he was young, about 10 years old. And ever since then, he's wanted to go back in time to be able to visit and spend some more time with his father. Totally get that. In the articles you read on him, though, he cites he was inspired by The Time Machine by H.G. Wells. And I have to, again, not trying to discredit him, but if that was really his inspiration, then if you've read The Time Machine, the very, very beginning of the book, chapter 1, first few paragraphs, talks about how time works and what real time travel would be. And, okay, travels through time. Inside the fourth dimension, time travel, and stacked time theory. Now, H.G. Wells doesn't talk about stacked time theory, but he does talk about the fourth dimension. Again, I said I was going to apologize for the reading, but just real quick. In the book, very first chapter, at the very beginning, the time traveler is hosting a dinner party, and he's talking to a group of people about traveling through time. And he asks this question: can a cube that does not last for any time at all have a real existence? Philby became pensive. Clearly, the time traveler proceeded. Any real body must have extension in 4 directions. It must have length, breadth, thickness, and duration. But through a natural infirmity of the flesh, which I'll explain to you in a moment, we incline to overlook this fact. There are really 4 dimensions, 3 of which we call planes of space, and 4th, time. There is, however, a tendency to draw an unreal distinction between the former 3 dimensions and the latter, because it happens that our consciousness moves intermittently in one direction along the latter from the beginning to the end of our lives. And he proceeds to dive into the concepts of how really it's our consciousness that is in the 4th dimension of what we call time. And in the process of putting together a short addendum to Travels Through Time, with some of the things that I've been talking about since the publication of the book. And one of those is that we are very interesting beings in that we are multidimensional by nature. Our 4th dimensional consciousness resides in a 3-dimensional body. And at death, when we pass away, that consciousness goes on. The body is gone, the 3-dimensional part is gone, but the consciousness still remains. And we even have scientists today, Stuart Hameroff, Roger Penrose. Scientifically, they've published papers on this, that yes, the consciousness does exist. And after we pass away, it goes on. They don't say where. They have yet to answer that particular question, of course, and we get into a very, very philosophical discussion that borders on religion. But it goes on. So that is our 4th dimension. Now, when we map out space, we need 4 points: length, breadth, height, right? All of that. Those are our 3 dimensions. The 4th, time. Why is that? Because as our universe expands, and just recently they discovered that depending on where you look to the outer reaches of space, it's expanding at different speeds. Discussion for another time. But in order to figure out any particular point in space, you also need the point of time. And that's because of the expansion. So, where we were 20 years ago physically, even if I sat here for 20 years on this couch, I would not be in the same place in space as I was 20 years prior, and that's because of the expansion. And not just the rotation of the Earth and rotating around the sun, but our galaxy, our solar system is all moving. And this was an interesting problem that came up. I have an uncle who's he's a retired nuclear physicist, and he did read my book, Travels Through Time. And after he got done reading it, he was like, it's very, very interesting. But when it comes to your idea of stacked time theory, so real quickly, the idea of stacked time theory, because that's a whole discussion in and of itself. Just take the idea, the concept that all time is concurrent, past, present, future, all here. And take where you're sitting right now. If everything's concurrent, that would mean every single moment that has happened, is happening, will happen, are all there right now. Every moment like a photograph in a very tall stack of photos. And he understood that concept. You take ideas of the block universe. Einstein had ideas on this. So he understood that. But his question became, well, if everything is here right now in this big stack that you're talking about, the problem is that where I'm sitting right now is not the same place in space as it was a year ago, 2 years ago, 10 years ago, 20 years ago. It's in a different place in space because of the expansion. And I thought about that for a moment. I was like, that's a really good question, Uncle Bill. I have one word for you, entanglement. And his eyes lit up at that, and immediately he said, yep, entanglement would do it. So the idea that through quantum entanglement, there is this infinite connection. We are connected to each of those moments through quantum entanglement as well. And what's interesting, sorry, I'm going to read a little bit more. And what's interesting is there is a recent study that has been published here, University of Cambridge, that back in October, this is pretty interesting, showed that they could influence past decisions. I almost want to call this the Biff Tannen effect. So, researchers at the University of Cambridge have shown that by manipulating entanglement, a feature of quantum theory that causes particles to be intrinsically linked, they can simulate what could happen if one could travel backwards in time, so that gamblers, investors, and quantum experimentalists could, in some cases, retroactively change their past actions and improve their outcomes in the present. Whether particles can travel backwards in time is a controversial topic among physicists, even though scientists have previously simulated models of how such space-time loops could behave if they did exist. By connecting their new theory to quantum metrology, which uses quantum theory to make highly sensitive measurements, the Cambridge team has shown that entanglement can solve problems that otherwise seem impossible. The study appears in the Journal of Physical Review Letters. And that's straight off of University of Cambridge's site. So now, of course, we have the ethical dilemma of them talking about them using this to aid gamblers and investors. Again, the Biff Tannen effect. Well, one of the examples that they used was, let's say that you asked a friend what gift they would like for their birthday. They didn't tell you, and to be able to send that person the gift, you had to get it to the post office by, we'll say, Tuesday. And they didn't tell you by Tuesday. You bought something else, mailed off the gift. On Wednesday, they finally tell you. By using this quantum example, again, this is in a quantum lab environment. By using this example, You'd be able to go back to Monday, change your decision of what you bought to be able to send the new gift on Tuesday and make sure the right gift gets sent out the door. They were able to do this with a 25% success rate, which doesn't seem like very big. But if let's say I placed a bet, say I played the lottery, if I had a 25% chance of bettering my odds by going back and changing that, I mean, think about it. You end up with we got a 1.1 billion lottery going on right now. If I found the right numbers the following day, went back to Monday, changed my numbers to the right ones, and I had a 25% chance that it was going to work, bet your lifesavers I'd do that. Bet your lifesavers. That's for my 80s brethren. So there are some real ethical implications when it comes to dabbling in all of this. And again, go back to the Future 2, and you can see fictional representation of what some of those ramifications could possibly be by being able to do that. But in any case, the whole point of this was the feasibility of using something like a black hole to move back in time is just not something we are going to be able to do, not even in our lifetimes, but in any lifetime soon. Now, we are at some point going to become a better spacefaring race. We've started to make these inroads to be able to travel the cosmos, but we're not getting outside our solar system anytime soon. The Voyager satellites they're just beyond the edge of the solar system. We've had problems communicating with Voyager 1 here lately, and that's been out there for almost 50 years. So you're talking almost a lifetime to get to the outer reaches of the solar system. So you're talking how long could a person survive? Would you have the resources to be able to do that, etc.? So using our current Newtonian physics isn't going to make that possible. We're going to have to try to find other solutions. We can use our current Newtonian physics to do things around our solar system a bit, maybe colonize Mars, maybe colonize another moon or something like that. But to get to the outer reaches, it's going to have to be something like using an Einstein-Rosen bridge, wormhole technology, something like this, which I'll say may be how, if extraterrestrials are coming here to Earth, which I do believe that they are, that may be one means that they are using to get here. Discussion for another time, for sure. But us getting out to a black hole anytime soon is not happening. I appreciate the work, but I believe real time travel will have more to do with the consciousness and meditative states, altered states of being, to be able to move in and about that dimension of time, up and down the stack, as it were. The analogy of a river of time is a good one. Time is the water in that analogy, but it's not the water itself that's making itself flow. It's the banks that are holding the water in place that making the flow happen. If you were to remove the banks, basically a control set that's been placed upon us, if you were to remove those banks, all that water would spill out. And you'd be able to move in and about large pond, lake, that sort of thing, as it was all spilled out, inaccessible. While Mallet says that his influence for researching this was H.G. Wells, and I would recommend he goes back and reads a little bit of H.G. Wells at the beginning there, mine was Somewhere in Time by Richard Matheson. And I really do believe that he was onto something there. Again, it's a fictional story, just like Wells' story was. But the idea that with Matheson's character, Richard Collier, that he was able to will his consciousness back in time, that has more to do with that. And Matheson's work was based on other researchers in the area, J.B. Priestley's Man in Time and others. So time travel real time travel is achievable by us today. And it's not some work of science fiction in which we have to wait for a machine to be built or for millions of years, however long it takes for us to be able to get ourselves around a black hole and survive. It's actually right here with us right now. It's the consciousness. All right, so that will do it for the mug for today. I do thank those who aren't usually with us for tuning in. I do invite you out to the Connected Universe portal, in which Mike's Morning Mug is just one of the many features that are out there. I have an entire course on time and time travel that I just recently published out there that is on it's part of the membership site. There's a standalone course on it as well. Of course, I have all the Mike's Morning Mug videos out there, monthly Q&As, the full Connecting the Universe weekly class, which you get the after show. There's a public side to that as well out on YouTube, but the after show is included, of course, there on the portal. Have all kinds of information and videos on ancient Egypt, Ireland, the American Southwest, all kinds of material that's back there for you. ConnectedUniversePortal.com. Till next time, time really exists.